Oh, heck, here's a network session. Connect. There's my port number. There's my baud rate. It's all set up, right? So
Oh.
instead of being in this robot arm thing,
Uh-huh.
this arm would be crab, and this network session would be the connection to your robot. And if it's not a serial connection, maybe we rewrite this network session to be a Wi-Fi session, a TCP/IP session, a UDP session, some other protocol, XB. I don't know.
I
Whatever
see.
hardware you put in there, we figured out one that we can work with.
I see. And the end goal, I think that would be good, is to be able to control the robot using like a RC remote or some type of PlayStation remote or something like that.
Yeah, that'd be cool. That'd be cool.
So what do you need me to do right now? Do you I have all the links if you want those.
Links to, you mean
The links.
the
The
length of each
links.
bone?
Yes. So this is
Right.
62 and this is
Okay.
150 and this is 300. It's pretty
I sent. I can't see your feed at the moment, but
Oh,
regardless,
oops.
I sent you a link in the general chat here.
Let me see. Waiting to appear. Wait, where? Oh, I see it.
Right. So, can you describe your legs with DH parameters?
Let me watch this video.
For axis of
Yeah.
rotation for every loop joint. This is the first joint.
Oh. Oh, so this is just like a standardized way to describe joints.
Now, if we add another joint,
You know what? Let's try it your way.
As before, this
Um,
the axis points along
which channel did you put the dimensions in, or can you write them here?
for efficient calculation
Yeah, I
of
can't.
forward
One second.
inclining z or the axis of the first joint. The x-axis is
Oh, okay. So DH parameters is just a way to okay.
The
So
convention.
yeah. So the only difference between mine and IK inverse kinematic and DH is my X and their X is like the X and Y switch. That's it. But basically it's the same thing, essentially. Okay, so coxa 62, femur 150, tibia
Coxa
300,
52 millimeter.
62
Femur
millimeter, 62,
femur
150.
150. 62 millimeter. Femur 150. Tibia 300 millimeter. But how far from the center of the body to the coxa?
How far from the center of body to the coxa? It would be different for every single one, I think.
Oh, they're not on a circle? Right.
It's yeah, it's a
Okay.
elongated hexagon thing.
Sure. Let's start with the leg and see where we get.
Okay. So wait, which one do you need?
Well, for all of them, ideally. But if we have the middle and the one, like the front left leg, the others are
Then
mirrors, right?
yeah. So okay, so I can just let me think. Oh, probably don't want to. Wait a second. Because these aren't these. This isn't accurate. These aren't like in place correctly. That's not good. Ooh, okay. Let me think. How do I? Wait, just give me a second. I can figure this out. Oh, wait a minute. I can just do that. I can just measure from one end to the other end and divide by two, right? That would work.
From opposite sides, yeah, yeah.
So it's roughly this divided by two, so 118. It's roughly 118. And okay, so this if this was in a line, this would be offset by 45 degrees.
Hold on, I
Wait.
can't see your feed.
What if I just... Am I streaming?
Yeah, you are. I wish it wasn't focused
Oh.
on that.
What if I just send this to you? Would that...
Where's your origin? It's in the middle of the green box, right? The world origin?
Oh, I don't even know. Oh, I guess it is. Wait, let me check. Uh, it's not. Oops. Not very good.
Hmm. It
Yeah,
certainly makes it harder.
yeah,
Well, what's center to center motor axle?
this
What's
one?
that distance? Yeah, because that's on one major
Uh,
axis, so that's something.
I just forgot. I think it's 118. Yeah, 118.
Center to center. Okay.
Or close to 118.
You're not sure?
It's 118, yes.
Try this. Try this. Pick that flat surface, that one you were just looking at.
Yeah.
Yeah. Now snap to that surface so you're looking straight down on it. Great. Open a new sketch.
Well, okay, that's the that's what I did,
To
basically.
measure the distance from the center of the hole to the center. Because once you
Yeah,
project them, you get a center dot, and you can measure from that to the other one.
right. But the
Yeah.
only thing is this isn't you see how this isn't fully this isn't like
Right.
I just dragged this here just to see what the
Right.
what
So
the it would look like.
your
So it's like
numbers aren't perfect.
it's not
Gotcha.
perfect, but 118. But this should are you able to somehow make this modular? Do you know what I mean?
Yeah, you can build one leg in a separate file and then bring it in here as an instance, move it around 6 times, and they'll all be perfectly identical. Um, but I just wanted a rough. I understand they're not perfect, but can we try that again and get the measurement from to the other
Wait,
motors,
1 second.
the corners?
I have a way, I have a way. This would work,
Okay.
100%. I just have to, yeah, I'll give you the measurements in 1 second. Okay, yeah, now I can do it. Where not? Okay, maybe not. Wait 1 second. Maybe this one work. Okay, I think this one should work. Okay, now I can actually join it together. So now it should be perfect. And oh no, all this random stuff everywhere. Okay, so yeah, it would be this divided by 2. So 235.8 divided by 2 would be the exact distance to the middle.
Hold on a second. From 235.82. Oh, that's
8.
very different from what you had.
No, divided by 2. It's pretty similar.
Yeah, 235.
I
I'm
think
going
I
to
was
call it
off by...
235 divided by 2. Now, what about the corners?
I'll do that next.
X and Y, please.
Dude, what is happening with this? Dude, I'm cooked. Like, I don't even know what's going on. There's too many.
Nice. Um,
I can't get the center point. Why can I not get the center point? Right there. One 38.7.
one. Wait, is this X or Y axis?
I'm not sure.
We're looking down on this. Okay, now can you wait? Can you info that?
What do you mean?
Hit the I key.
The I key?
Yeah. Doesn't it make a pop up in the right? No.
No, it
Dimension
doesn't.
it. No, there's a way to show you both the X and Y dimensions, not
Oh,
just the straight
are you
dimension.
talking about like this?
Yeah.
The second
Yeah.
view? Oh. Uh. Oh, I can just do this. Right?
Right. That's why I wanted a sketch before, because you just snap those lines in and boom.
Okay, so this is... Okay, if we're saying this is Y, this is 113. Let's just do 114.
114, and the other one
Yes.
is
The X is 79.
79, and I can't see the motor in the center anymore. I guess you hid that part.
The motor in the center? It's
The
right here.
center, no, that's on the corner.
Oh, it's this
Cool.
right
Can
here.
you remeasure that to the center? Put another line there. Cool.
118. So yeah, I was pretty
118.
close. 118, yeah.
Awesome. Okay. Uh, du- 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 du. Du- 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 du. Okay. Femur, tibia is La 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 la. Okay.
Wait, are you modeling it right now?
Yeah.
Oh, wait, why is it? I can't see it. I want to see this.
Uh, let's try that again.
Oh wow, you're type. Wait, can you explain what you're doing? This is interesting.
Sure. Um, this is in Java. This is the same. This you see, so this program, this
Uh-huh.
ARM has these nodes, and some of them have like this has a mesh instance, and this has a material
Uh-huh.
on this plane, or in this case, the leg has a base which has a mesh and a material, and I can go into this material here, and I could say like make it orange,
Oh, I
and you can
see.
see the color right it is changed because these nodes all work together. They play nice. I can go in here, and this is the OBJ file. So if you
Oh,
can
this
export up one bone
IK.
of your robot as an OBJ file, I can drop it into here, and now it will. Then I'm building this relationship right now, so that the whole thing goes together. So I build one leg like this, and then I say down here, give me 6 legs, then change the position and orientation of each of the legs, and like that, we're going to snap together a model quick, fast.
Wait,
Um,
this is the femur. Would you? So you would like something like this,
yeah,
right?
yeah.
Can 3D print do OBJ? Oh, like this, right? OBJ.
You should be able to export the whole thing as an OBJ.
Oh, you want the entire thing as OBJ? Oh,
The whole
like
thing,
this
the
entire
way you
thing?
had it, like that, yeah.
Oh,
So wait, if you think of a bone as all the pieces that move relative to each other without, right? They never, like,
yeah. So this
I
part moves
imagine
all
one,
together.
sure, and I see and then on the tibia is where you have the motor.
Yes.
Understood. Yes, yes.
So you want this entire thing as OBJ.
That'd be awesome.
Okay.
Um,
How do I do this? Export OBJ. I think OBJ is what like what's it called? Blender.
Blender supports OBJ. They didn't make it up. Yeah.
Yeah, it supports OBJ. That's the only place I've used it. That's what I mean.
Um, okay, I'm just going to go with a box.
I sent you the femur. So basically, you wanted me to send you every joint that moves to like all the parts of the bone that moves together, basically. So like
Yeah,
cox as a full.
yeah,
Okay.
yeah. The torso would be one, the coxa would be one, and so on. So
Okay.
in total, you have to export 4 models,
Okay.
and it's much easier for me if the origin of each model is set up nicely. But with your help, we'll be able to correct it very quickly. Um, sure, let's go with that because I don't have the files yet. We will get there. Um, so now I'm adding both a mesh and a material to all 3 joints. And I've made them all children of each other, and I've set their position. So now when I make an instance of this crab robot, and drop that in the world, it should instantly create all these components. And that's good enough for a test for now. Uh, mm, mm, mm. Uh-huh. Okay. So I've got this crab, and now I need to publish this crab, which means back in the registry, crab BD, so it'll go here, node, add, because I don't automatically alphabetize these. Although that would be very clever. I've had bigger fish to fry. When you get one of the parts exported, try opening it in, you're on Windows, try opening it in the Windows like 3D mesh viewer and see what it looks like.
Okay. This is the
Just
last
as a
part.
little test. Yeah.
How do I...
Add
Why is this...
crab. What are the rest of my nodes?
Oh no, exceeds the file limit. Ah...
Nice. Now we're getting somewhere.
Do you know how to use ROS 2?
No.
Oh,
When I first encountered ROS and ROS 2, they required a special Ubuntu installation, which
oh
means
yeah.
you need a partition on a drive and a dedicated Linux box. And I was like, fuck that, and started writing Robot Overlord.
I see.
So yeah, maybe I'm a little bit of a sourpuss and a hardhead, but at the time it was, and then I got really invested in this thing. So is it the best solution? I don't know, but it's what I got. So here I have, can you see my screen for a moment?
Yes, I'm watching it.
Yeah, so I have here the crab with a coxa, femur, tibia, and there's a box somewhere out here. Don't ask me where just yet. If I try doing this, does it appear? No. Oh, but this might be meters instead of millimeters. I might have to make this like this, and this, this. No, that didn't work.
That's in centimeters, right?
Copy, paste, paste. No, you're not going to let me? Dang. These are in millimeters, and I bet it's supposed to be in centimeters. So, okay.
How did you learn how to code?
Same way you eat an elephant, one bit at a time. Add mesh material to this node. This node has a child. It's a new material. This gets added. This gets added. So what's the problem? Why aren't you adding it to all of them? Femur, tibia, and toe. In fact, coxa should have one as well. And so should this. Why don't you like... But I am a node. What's wrong with this? Provided leg. Oh yeah, that wouldn't work.
Do you know how to use reinforcement learning?
Reinforcement, I know of it. I have never successfully completed it. I tried building a robot dog in Unity and using their machine learning models to use reinforcement learning to run like 16 dogs at once on a flat plane, and they were all trying to learn to stand up. And after running it for weeks, I got nowhere, and I gave up on that one for now.
I see.
So all I can say is I've tried and I followed the instructions, and I have not been successful. And if you figure it out, please let me know. I would love to see that.
It's a pretty cool concept though. It's like
I love it.
how
Yeah.
all humans, how all anything learn how to actually move, trial and error.
I feel that there's something wrong with the way they train them up. The way there's something that feels intuitively wrong about the current method of weights and biases and doing it once, and then your model is sort of frozen and it can't learn anymore after that. And like the human brain has chemicals and can trigger its own chemicals and can enter into the right feedback loops to learn things. And those chemicals alter the neuron weights. It doesn't just make guesses. I mean, you do make guesses, but it is a way of concretely solidifying new experiences that are retained, and that's you learned a lesson and that's written into your neurons.
Yeah, I see.
But there's no way for the AIs to do that. And I would love to see a way to figure out a way to do that, to simulate that in the computer, so when the crab falls over, it realizes, oh, that hurt. That makes a core memory now, and I don't do that again because I know that path leads to danger. That would be amazing. And I'm yelling because I'm wearing the headphones, so I can't really hear myself.
It's okay.
Add measure material cannot be referenced from a static context. What's your problem? From a static context? So maybe this is... Now you're happy. Great. Add floor. Then in the scene, add one crab. And show me my scene. Well, there's a cube. That's a start. That's a cube. And in this coxa, I have a mesh instance, but it does not show a box. Where is that bone at? Oh, look at the bone. Here. Oh! Oh, hello. Suddenly you all appear. That's fantastic.
Wait, so what you're doing right now, in simple terms, what's the easiest term you can describe? So you're writing a code in Java and then
I
exporting that
wrote,
to your...
yeah, that's right. I wrote a little class that holds a leg, describes one leg as a coxa, femur, tibia, and a toe. And then I connect them together like this. The femur the coxa is connected to the femur is connected to the tibia is connected to the toe, and then I give them all names,
Why
right?
did you
So
add a... What is a toe? Like
the
the...
toe is where the contact is made with the ground.
Oh, I see, okay.
Thank you. Great question, by the way. Um, Maybe it's better to do this and don't put two things on the same line. So then I set positions for each of these bones a certain distance away from the origin in a line.
Oh, okay, so that's the
Okay?
thing you were telling me to get, right?
You got me those three numbers, yes.
Yes, okay.
So it's then in here I add a blank mesh and a blank material
Oh,
because
that
I
should
don't.
add the box thing, right?
That's exactly right. And when I look at the simulation here, I can see I have the crab mesh, which is in the center, which is actually, where is the crab mesh? Let's look at that. You're over there for some reason. Okay. And then the coxa is way over here. And I bet if I do this, yeah, yeah, you're too big. Let's close that down. Let's go back up here and adjust these numbers. Well, you are lower, so what's your problem? If this comes out again if this coxa comes out as a huge number, I'm going to be very annoyed. Go back to the scene, add a crab, hit OK. Do you have like, I think the free Java built IDE is called Eclipse. Do you have that?
I have
There
no
they
idea.
are. There they are. So why are you 115? Where does the number 115 show up anywhere in here? That's where I add the 6 legs and I put them way too far away because I just goofed around and was like, this should be 360 divided by 6 to make them spread evenly. Now, if I remove that and add the crab back again, I don't even have to stop the app, and I can make a lot of fixes, which is one of the reasons I love, love, love Java. Okay, so here you see I've got 6 legs going out in each direction,
Right.
and if I
This is a perfect, like, it makes a perfect hexagon, though, in my robotics, like,
yes, because I did my first draft, get it working, then get it pretty, right?
okay.
So here's our coxas, which are all smack dab in the center. So this is apparently too close. Why is this too close? If I make this a 14, I make this a 15, I make this 150, it's far away. So I feel like that's right, but where's the mesh for this? That doesn't feel right. You can't all be at over there. Is that the world origin? No, it can't be. Right. I want you to be positive 15. And then the next box should be whatever that is. Should be 6.2. Did that go to where it's supposed to be? 1, 2. They're swapped. Don't show me just show me the positions. Oh, it doesn't remember them. How annoying. Um, Maybe my rotation here is backwards, and that's because maybe I've set the position backwards. There's 15. There's this. There's this. The tibia should be 30. The tibia is longer. Okay. Then who are you? You're in a completely different leg. Reduce to one leg and look at the problem more closely. 2, 3, 4. Oh, you're way out there? It's very strange. There's something funny going on with my meshes. They're not appearing where they should. At least that's my fear. If I don't translate them at all, and I just cause them to come into being as a single yes. Now, if I remove all the legs but one, yes. There's the femur. There's the tibia. There's the toe. And those sizes look correctish. So if I undo, and now I look at this one, yes, 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 fantastic. So now if I take a femur here and I rotate it by 40 degrees, the leg moves as it should. That's fantastic. And this also moves, but it's moving in the wrong axis because it needs to be rotated. That's more like it. Easy enough. But that means that procedurally I have to rotate each of these joints to get the rotations correct. That's not impossible. Do you, by any chance, do you have those OBJ files now?
I did. I sent them all to you, but
Oh, snap. Where did you send them?
Discord.
Direct message.
Yeah, but also
Oh.
I don't know if that's what you wanted because I think there's many components within the OBJ. I don't know if that would work.
We'll try. Visit site. Just slap it on my desktop. In Robot Overlord test scenes. We have a crab here, but we're going to make a new folder. How? There's a how or now? How?
How? Like H-O-W.
H-O-W.
But it's
spelled H-A-W. H-A-O.
Yeah.
H-A-O, what's your last name?
Chen. C-H-E-N.
Done. Great. Hey, can I get an email?
Email? Yeah.
Yeah.
H-A-O.
Uh-huh.
C-H-E-N.
How Chen?
880
880 at
gmail.com.
Great. If for some reason Discord disappears now, I went next to the files and stuff. I know exactly what I'm talking about. Download this whole thing. It is downloaded. There's only one file in here, Coxa.
Oh
Okay.
yeah, I sent the other ones are they're small enough for me to send on Discord, so I sent them directly.
Oh, okay. Discord. I see them now. Femur.
Wait, can you explain what an OBJ file is?
Sure. It's in short, it's a list of points, edges, and triangles and colors to describe a 3D model of a shape.
I see.
I don't remember which. I think it's best for video games because it's not good for machining, and it's not good for 3D printing. You can keep all the internal faces that you don't need, and even there in video games, they would chop all that shit out.
So it's basically like a mesh with color.
Yes.
Okay.
There may be advanced features that I'm not aware of, but I'm not aware of them. So in this mesh instance, can you see my screen now?
Yeah, I'm watching.
Okay, so I was so pleased when I got this whole tab thing working. Oh my goodness. Oh my goodness. From a file, choose it, load an item, go back to the test scenes, get the How Chen file, do the body. Okay. Are you there and you're just really small? Is that what's going on? Like all my dimensions are way off? Let's see if I can I scale this? No, I can't scale it. Look at the
I
part.
exported in millimeters.
Okay. I think it's me. Like you said, I should actually open this first in something like Blender and see what happens. Open with Paint 3D. Well, too slow. Blender.
Blender runs so much faster than Fusion.
I don't think Blender is trying to do everything in the cloud.
Yeah.
Import OBJ, desktop, test scenes, Hao-Chen, body. Aha. So, and this is a unit 1 cube. So
Unit 1.
I'm
Like 1
like
millimeter?
there's your part.
Oh.
Here's your problem. It's too big.
Why does it look all wonky?
It's not loading the triangles correctly.
Is that because
It's
my
probably
files
something about, I think it's the way I'm loading OBJ files. So it's unfortunate that it's so big, but we're going to work with that. If I do this and I say export as an STL file, and I go back to
so I use the 3D
the
print?
test scene, yeah, and it's more tested. Body, STL. And then here in this mesh instance, instead of OBJ, I'm going to try the STL file.
Oh, wow.
Right?
Looks better.
Yeah,
A lot
it's a
better.
little too big, but we're on the right path. If I then take this and I scale this to 0.1 and 0.1 and 0.1.
Because the dimensions don't really matter. Wait, does it? Or it's just like the ratios, right?
I scaled it all down linearly, evenly.
Okay. See.
Reload this. Look at this part. Zoom in on this part. Oh, it's on the center there. Right. So there's a little problem that this mesh also needs to be rotated and put in position, which is why like I have to fix this in Blender because it's not fixed in Fusion. But once it's in the right place, then it automatically loads right in the center where Crab expects it to be.
And
Otherwise,
that's because I didn't have it correct where?
yeah, the other way is that I change the position. Like, what's a good example? I'm gonna have to close this down. But in the node here, I can write in something janky that kind of fixes it. Like, if I go to update in here, I can say this get child, no, find first child mesh instance. So this gets me the mesh body, and then I should be able to say, and I can adjust No. Okay, so then here I can set the position to whatever I want, and that will again adjust this mesh. So if I know, I click something like this, and I use the measuring tool. Where are we at here? Measuring tool, measuring tool, measuring tool. See, I don't know this one as well as I should either.
I don't know Blender either.
Ruler, 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 ruler. There it is, measure. It was around here somewhere. So that's 19. Let's try. What's wrong with that? Oh. Okay, you insist on it being a vector. That's fine. So this update runs every tick.
So what
And
this moves the position from
this moves
to
the
the
possession of only the mesh file
to the origin, right?
to actually back here in this body mesh. Body mesh, set mesh, registry, mesh factory, load. This is again a spectacularly terrible way of doing it, but copy as path. Sure, if that works. Illegal escape care. So you want me to do it this way? Users. I should do a find and replace all, but I'm being stupid. Okay. Okay. We're
Okay,
nearly
so
home.
now you centered it. Now you gotta rotate it, right?
Yeah, exactly. So here in...
But that's not perfectly centered, right? Because it was just a guess.
It was a guesstimate, yeah.
Okay.
But it's good enough for our purposes.
Yeah.
Is that upside down or is that right side up?
It's upside down right now. Okay, there we go. That's good.
Okay. But the dimensions, that's not where the coxa is. The coxa is like out here.
Right, and yes.
So the mesh is still too big?
Wait, so the coxa is correct, right? The coxa distance, you already set that to be
Hold on.
1
Did
AQ.
you export, when this was built, was this built in inches or in millimeters?
In millimeters.
Huh.
That's why I was wondering why I exported so big.
Yeah. Yeah, I could see if it was 10 times bigger, but given the position of these cubes...
Wait, the coxa are where they should be, right?
The coxa is right in the center. It's not where it should be. It should be positioned a certain distance from the center. Okay, so that, we're on the right path here. We got them all to load. Then we got to go back to, it'll be this, legs, get. Let's start with leg 0, coxa, set local, it's M again. I gotta make a separate one so I don't screw up the old one. And set translation, copy this, boop, boop, boop. And we had the number from up here. It was this distance, right? I think.
That's
So
the
it's...
distance of the coxa. That's the bone.
Oh,
coxa
sorry.
bone.
No. Yeah. It's this one. It's actually this. Set translation to center coxa. And we can say 1, 2, 3 legs later, we do the opposite.
Wait,
So this is
what you're doing right now,
center
saying-
leg left, x plus center leg right. No, you're not going to let me do it that way. Well, screw you.
Are you setting the coxa length right now from the origin?
Yes.
Okay. And you're doing the the Pythagorean theorem thing, right? Earlier, the triangle.
I will be. I will be. Yeah.
And right now you're just doing the middle one, right? The 118.
I'm just doing the middle two legs, and then I'll work out one at the corners, and then I'll mirror it.
I see.
Right.
That makes sense.
Okay. So
That looks right.
okay. Then what's this? What's this cube? Oh, okay. So it's from a different joint, and I don't need to worry about it yet. Okay. Maybe that's from the other side. Screw you. So this one, this guy is actually. Right.
Mm-hmm.
So that when I I should have center left, center right, and center right inside it. The hell, center right inside it just has a femur. See, because it's pointing the wrong way. M wrote Z 180. Excuse me. It takes radians. Is it fixed instantly like that? Just from it built, right? It built. It didn't say it complained. Center right, femur. You're in the wrong spot. Was it not a rod Z or oh, it doesn't apply it. Center. Because I rotate, so when you do set translation, it smashes whatever the rotation is. And if I'm not mistaken, it also, yeah, I know. So you have to rotate first, then translate. It's a rule that's not obvious. So there is my femur, then my tibia. It's just a rule in the implementation of matrix class in this app. It has nothing to do with the rest of the world. Okay, so we got those two legs going. Now let's do one of the corner legs.
Each of those cubes is where the joint, the
exactly.
Rotation. Okay.
You got it. Var. If I can just do this. Right, so then there's less numbers to repeat. Repeating is bad, and because this is the 0 unit, the first one, it offers me to say get first. I'll do it just to make it stop complaining. Okay, so no. Okay. And then it would be what, like front right? Maybe. We'll see which way we go. Do 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 do. Do 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 do. It's what is the rotation there? Is that 45 degrees?
What do you mean? From the other? You're doing the other.
It looks like the front two legs are pointed 45 degrees
yes,
from the major axes.
Yes.
Yeah. Yeah. So why was this one rod X if this one was rod Z? Because that's the adjustment for the body mesh file. Right. Yeah, I can't do that just yet. I'll do like this. Because that's all going to move into a method the next time I restart the app. This is front right. This is probably 45. We're going to see how that goes. And then instead of center, 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 it's corner, 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 corner. Let's try it that way. And this will be leg 1 for starters. Yes. That'd be front right. Stop that. Who's it going to be? This one. That's front right. Okay, so it looks like it does this one, then this one, then this one, then this one, going around like that. Does that make sense?
Yes, that makes sense.
Wow, perfect. So, I mean, does that match your, you don't care, well, we'll work out which servo goes to which leg in a minute, right? So front, left, and then this is plus 90, and this is, why not use the full name? Oh, there's so many years we did not have good find and replace. And it's one of the reasons I work in Java is because the tool gets out of my way. Python has a lot going for it and a lot of code written for it, but I have to get to, it still feels to me like you're just writing in the DOS prompt, like on the command line. I haven't seen an editor that is nice. If the guys who made this editor made one for Python, I would seriously consider writing a lot more Python.
I see.
So that's
And an
front right,
editor.
front left, center
That's-
left. That gives me tools like AI code completion
Oh, I see.
and
So it's
easy
like
ways to
VS Code,
change
right?
names. Yes, I don't write C++, partly because it doesn't have no garbage collection, and you have to mess around with the pointer. The syntax of writing out pointers is ugly, but I understand there's a lot of power there. Java is simple, and again, gets out of my way, and I know how to write unit tests in Java and run them every single time I check in my code. So I have like 200 tests in Michelangelo alone. Here in this thing, I have a lot of tests. Okay, not as many as Michelangelo, but I got a lot. So that when I change something, I don't accidentally break everything I've written beforehand.
I see.
I talk a lot.
It's okay. Good information.
Thank you. Then these would be back. Hey, back. And this is back. And these are swapped. That was 3. This is 4. This is 5. This is plus 90 again. And then this is 93 times, or the third time. And then this is, and
Wait, there is actually a front and a back to the hexapod,
okay.
but it's symmetrical. So I think even if you, okay, so if you look at this, you see the top is the front.
Hey, why'd that one not rename? Oh, okay. So that's the mesh. That should be 0. Front, not front right, center right. Yeah, this is, let's see, this has to be get 0 so I don't get confused. So that's the first one, the second one, the third one, the fourth one, the fifth one, the sixth one. Perfect. Front right.
Okay, that should be technically the back. Wait, yes.
I can do it. What is the problem that the LCD is going to be on the wrong side?
And the tail and the orientation, but I don't think that matters too much. Maybe you can just,
You know, what I can do is rotate the mesh.
yeah.
No. Wrong location. This one. Wrote X. Yeah, it's getting late, hey?
I mean, it's okay.
Yeah. Well, we gotta be good to ourselves because if we aren't, the factory won't grow. I've been playing too much Factorio. Sorry. Is that all it takes? I hope so.
Oh.
Not quite. Let's try. You have to get your matrices rotated in the right, done in the right sequence, or they get annoyed. That should be exactly the same as we had before. Yeah. What if I try instead to do this? It should have been in the center. Where's the center of the crab? Really? Nope. Lying to me. Okay. Now you're just upside down. Okay. So then front right is here.
Yes,
Front left is getting there. Where's just the center left? Front left. We got two. Okay, we got two and the mesh. We're doing great. Front left. I said plus 90 on this rotation, but that wasn't good enough. Did it dupe? Yes. And then this is correct. So this is a negative. But this should be a negative, and this should be a negative. Center right, back left, back right. Ha!
that looks right.
Feeling good. Okay, so I am going to stop it this time because now that I've done all that, this does not need to be in every update, every frame. This can be in here, and this method is far too long, so this will be called something like, yeah, exactly. Mm. Okay, and all that's happy. So now I can just, boop, I don't need to look at you anymore. And then back, this is the fix the meshes, right? So fix meshes. Great, that's the body. I realize there's a lot of copy paste, but holy moly does it go fast. So coxa mesh, right? So that would be leg. Can I get away with that? Well, we're going to find out. Legs get I. Leg coxa. Find first child mesh instance. Load. Right, and this file name is from the coxa. I don't know why I keep pronouncing it quite like that, but whatever. It's fun to say. Copy as path. And I need to change all these out again. So cool. Uh-huh. mesh femur. And that'll be femur. And this will be tibia. And I can put all that in update again because I want to monkey with it until I get it to work right. Monkey. Ladies and gentlemen, the heat is starting to get to his brain. Crab. Here's my crab. Where are my mesh instances? Mesh instance. Well, it definitely lists something there, but it's listing... Oh, it's for the wrong mesh. What went wrong here? This... Oh, we could just find in the coccyx each time. This should be in the femur.
Also, I think the nodes are in the wrong
tibia.
instance again.
I haven't resized these yet, right? So, back to Blender. Go away, cube. File. Import. OBJ. Desktop. Test scenes. Chen. Coxa. Change this down to 0.1. 0.1. 0.1. Okay, we're going to go with that size, but now the origin that you gave me for the code is in the middle of the motor, right? Is it this point right here?
Yes, that's, yeah.
Okay.
The axis coming out at us is the z-axis, right?
Based
on the thing we said.
No, but there's a whole shenanigan that happens because by default, Unity, Blender has Z going this way and Y going that way. But when you export, there's another. Sorry, I gotta have this selected. File, export to STL. There's this whole thing about which way is forward and which way is up, and this makes me insane. Because it does, I don't, the convent, it makes me insane. So, did it do only selected? Well, there's only one file in there. It should be okay.
Oh, wow.
Still a bit too big, hey?
And it's rotated the wrong way.
Right, because when you export this part, it's in whatever the local thing is. It's not all, you built it a certain way and it worked great, but now, yeah, okay. Cost of doing business. Well, I want to rotate 90 degrees on the dot. Let's undo that. No.
Oh, you see the side, the right side? You can just put 0 for rotation X. Yeah, there.
But that's the way it was already, and I want, right? Wasn't it?
No, I think that's right. This is right. You had it at 90, I think.
Okay. Huh. Export, STL, do the thing again. Julie, do the thing. I have to force it to reload, don't I?
Okay, there, it's right now.
Yeah, and it's the right size?
Yes. It's just
okay, so it looks like the center of the mesh is off on another axis. So if I rotate this, yeah.
Oh, okay,
Yeah, I didn't check that.
Does this have to be like exactly centered? Where is like
Basically, yes. 4 and 4. I think I go down a little bit like this. I'm using the gray grid to eyeball it. You're like, yeah, that looks about right. And then go back this way. I wish this line showed over top of
Wait,
this mark.
go back to the other view, the one you just had it at.
1 second. Good enough.
Okay, I think that's good. That's centered. Yeah,
Yeah.
that's centered. Yeah.
Okay, cool. File, export, one more time with feeling. And then reload it. Nice.
Oh, nice.
Nice.
It's down a little bit too far though. It needs to be up a little bit more. Uh, if you look at the
I see what you're saying, but what I want to do is get this to a place where, like, you've seen how I do this, you can do the rest, and then we can meet up again when the mesh is completely built. Okay, so that's held in place now, but so unfortunately, because this is it's only affecting the mesh here, right? So now I should be able to say, hey, rotate this 90, and it rotates on that point. See, so okay, so
you can just
the model
translate
that you
that.
exported of the Coxa includes this motor, right?
Yes.
And it shouldn't, because this should be locked on the body.
Mm,
When I rotate around the origin, right? Because that motor
oh, I
that's
see.
locked to
Yeah,
the
yeah, yeah. You're
body,
right. You're right. You're right.
you're treating both sides of the joint
Oh
as
my
a single
goodness.
piece,
Yeah,
which is
yeah.
understandable.
I
But
forgot. I
yeah,
forgot.
that's okay. So these models would have to be re-exported. What I'm going to do, if I go into here, this is
Wait,
Crab Robot. If
are you
I
able to just separate the mesh? Like cut the mesh where?
No, I'm not.
Okay.
I would love to be able to, but I'm not. What time are we now? 10:52. It's a Saturday night. Sure, let's go. Coxa femur tibia. We got the tibia mesh hasn't been exported yet, so I'm going to go here. I'm going to go import to the OBJ to the tibia. Now this one should be fine because the motor's on this portion. First off, I have to do the 0.1. A 0.1, please. Opposite sides of the keyboard. Okay, and then looking down on it from above, yeah, I want to move it so that this is on the center. And I do believe I want to move it. And how do I want to reset the origin of the part to this location, which
I have
would
no
make life
idea.
a lot easier.
Wait, also, how do you want me to export the new OBJ for the Coxa?
The motor that's attached to the body should be part of the body mesh.
Do you want me to send you a new body and a new Coxa?
Yes.
Okay.
Yes. That would be perfect. Can you move them? I guess you can't move them to the right position so that they will work on my computer. Because I have to like swap back and forth between the two programs to get it right.
Like Blender and
Yeah, so I got to do it myself because
uh,
for now, and when you have a copy of this thing running on your computer, you can do it locally and get it done in a fraction of the time. So,
I'm gonna be honest, I
again,
started learning how to use Fusion like
uh-huh,
3 months ago.
uh-huh.
So
That's fantastic.
still working on all the shortcuts and working on how to do everything correctly or more
Maybe
efficiently, I
it's
say.
maybe it's in sculpting. I don't know. I'm trying to find the origin, and I want to reset the origin. Wait, this is a perfect chat question. Hey, how do I move the origin of a mesh in Blender 4. The triangles should stay where they are. The origin should move to the world origin. Yes, select your object, press Shift S. Oh, maybe I have to do it in layout. Shift S. Cursor to grid, cursor to world, cursor to selected. Cursor to world origin. Yes. Then object mode. I'm in object mode. Yes. Then right click on your object. Set origin. And then which one? Origin to 3D cursor. Oh, nice. And I want to rotate this so that the fingertip is right there. Yeah.
Wait, should I, okay, so under the body, there's batteries. Should I put that in there too, as well, so you know where
That would be a good idea. Then we
So,
know if we're
okay.
actually clearing the ground and things
Yeah.
like that. I like the way you think and wish to subscribe to your newsletter. In fact, I already have. Awesome. Now if I go back to this one, no, it's in Tibia. Hey, why are you too small? You're so small. Why are you so small? You shouldn't be that small. This one was exported at a different scale from the others. Okay, we're starting to get somewhere. Let's try rotating this model in here, and maybe, just maybe, we'll get super, super lucky. And then I have to center it. About 4 each. Yeah, it looks like it's 4 each. And then on this side, it's at the origin-ish. Set origin to center of energy. Origin to, so no, I need 3D cursor. It's in object mode. Shift S. Cursor to world origin. Okay. Export as STL. Tibia. Export. Reload. Hey, that's looking good. Yeah? What do you think?
that looks good. I'm trying to export this as the components with the relationships, but I don't know how.
Export this as the component with the relationship. Hold on, let
Because,
me look at your screen.
wait, am I streaming?
I don't know. I'm just trying to find your. Yes, you are.
Okay, so right now I need to
Okay.
put
Show the
this.
body.
This is the body,
Right. Okay. All one
and
mesh. Love
and
it.
I need to add the coxa
M-
servo on there.
Yep. Yep.
But all there's so the one, two, three, four. There's different components, and they're all joined together by relationships, like
Okay.
joints, rigid joints.
Okay.
But when I put this here, it's not. The relationships goes away. I don't know how to import this. I
Can
don't know.
you put all of these into one mesh, one Fusion 360 file with their relationships?
I can't, not
For
right now, because
okay.
this is
So,
the old this because I haven't put the new femur. This is the old femur.
mhm.
This is 200 millimeters. The new one is 150, and I haven't put that on. I haven't figured out how to do it yet. So I'm just trying to put this part on
Uh-huh.
here,
Yep.
but I don't know how. Um, huh.
So the way I would do it is to build. I don't have Fusion 360 open. I'm not going to go through the update process right now. Um, the this repeating section with the motor and the housing around it,
Yeah.
I would save that all as one Fusion 360 file, and I believe I would build one. Can you look in the in assemble? If you drop down assemble, I believe it is, or it's like it's an as-built joint maybe, and so the body itself is anchored. If you right click on it, I believe you can select an option to anchor the model.
Anchor?
Yeah. No. There's a way to anchor it which says that this is a part of the, like, it's a foundational part, nothing should move. And then
Oh,
when you
it's like
assemble other components relative to
a
that, it tells the
ground
system that
parent. This thing.
that's the one. So you can ground all these parts, but you can also build if you ground, yeah, you ground all these parts in the center, and this whole block you ground together as one, then you can import that as an instance in this part, and it stays as a single unit. Um,
Huh.
and you can move because it's an instance. It's like, how in a video game they'll build a model of one of the imps in Doom maybe, and or Steve in Minecraft, or a sheep in Minecraft,
Right.
and then when they instance it, it's the same model just positioned somewhere else, and you got to do the same thing here.
Okay. I'm gonna. So I can import all of these guys. I can import this, but they won't be. So this is here. Now I gotta move this. Oh, wait. I can. But you see how each
Yeah.
one of these are separate? It's like
Right,
separate.
but so instead of bringing them into here, can you bring them into a new separate file? Call that like
Oh, I can.
shoulder assembly,
Oh,
and then bring that in here. And then all of shoulders assembly will move as one piece.
okay. So cox assembly, insert. Uh, so all this right in this one. So click
I'm
OK,
not looking 1 second. Yes, all of that.
and
And
then
and yeah, go ahead.
and now what do I do? I could just. I mean this, or I could just combine all of them, right? So just be one piece. Oh,
Yes,
never mind. It doesn't
you
work.
could, but you can select all and then make a constraint. I think it's under assemble. You can make a joint, and the joint is a rigid joint.
What is
Yeah,
happening?
no, don't do that. It's not a rigid joint. There's another type. It basically locks everything down and means that
Oh,
nothing can move. Jerks.
I don't see this guy.
Okay, cancel out of this. Just save this file. This is the one you called Coxa ass. Okay.
Cox has
So back in
symbol.
so back in your body,
Wait, so save this. Sa
you've already saved it. You just hit like
okay.
Control S or something. Right. I think because you're using a cheaper version of Fusion, they're going to say you have a limit of 10 editable files. This is some bullshit, but you can get around it later. So now, these parts that you brought in here before, these are not part of the assembly. Remove them.
These.
Yeah. Now drag Cox assembly into here.
You can do that?
Yeah.
Oh, that's
Now move that where you need it to
crazy.
be, and let's make sure that all the parts move together.
If I do a joint, would it work? If it doesn't, then I can just do a move.
Yeah, it
Okay.
didn't because you didn't joint all the parts together in the assembly file. You can do that, and then it'll work.
So here,
Yeah,
I need
you
to join
joint all these
everything.
together. But the joint
Uh,
type is supposed to be rigid joint.
yes, that's what I have. Like here, that's what I have here. But I just don't know
Right.
how
So,
to
but you
move
do
it.
it if you do it once in the Cox ass file, you don't have to do it 6 times.
Okay. Can I even? So this and this will go together. And this one.
My femur's a little too big.
This one.
So we've been at this for about an hour now, right?
Yeah.
No, it was like
Maybe a
eight
little bit.
o'clock when I
Yeah, a
started.
little
It's
bit
been
more than
3 hours. It has been 3 hours. I have underestimated this, but here we go. Here's a crab. That's a gorgeous looking crab. I select move and drag it up a little bit.
Hey, I
And
made a
now
move.
he's sitting on the floor.
I was gonna
And in my
paste.
environment,
How do you think we could generate the walking gates?
oh, we're getting there. We needed the mesh first. We needed the model first.
So we need to
So we
make
can
them closer
visualize
then.
what we're doing.
Okay, I
Yeah.
see.
As a bonus, I already had a system in that does shading. So we get beautiful 3D rendering with shadows and all of that goodness.
What
Uh,
PC do you like? Do you have a nice PC spec?
oh, I don't think so.
Oh,
I'm running an ancient video card.
ancient graphics
I
card.
was yeah. This friggin' thing is a Radeon. Where's my settings on this? I'm not gonna.
Wait, so everything about coding everything you're doing, you learned it by yourself, like slowly.
Basically, yes.
That's crazy.
RX 5500.
RX 55. Okay. Okay, so this is what you want, basically. This is the body.
One moment.
I think this should work.
You can buy my video card now for $180.
Okay.
So it's old. And yeah, that looks fantastic.
And then I'll also need a coxa, just the
Yep.
coxa, just this
Yeah.
part. So
Yeah.
where did I do this? This is the body. This is here. So coxa assembly.
The shoulder of my crab combined both motors from the coxa and the femur. Sorry, the motor that's on the body and the motor that's on the coxa, I put them both together in a block, and that was the shoulder of my crab
Oh,
robot.
wait, let me see this. I need to look at this. This is so cool.
What?
The simulation thing.
Yeah, I told you, with the shadows and the lighting. If I turn this off, there, that's a little easier. Right? And I can then...
Whoa, that actually looks crazy. Wait, also,
My rotation tool is ass.
one other thing I think would improve performance. If you go to a top-down view, it would be like, I think in my mind it's most logical if all the legs are spaced evenly. The tip of the foot is spaced evenly, so it can have the largest walking gait. Does that make sense? Kind of.
Then the body would be a circle?
No. Okay, so because it's mounted at 45, you see
If this toe tip came into this line, is that what you're saying?
No. If okay, the top two and the bottom two are closer together. Yeah. So okay, how do I explain this? Okay, so like the bottom 2 feet is closer together. You see what I'm saying? Then whenever it walks, it'll have the largest range of motion possible. If all of them are even. So we can just the coxa joint, the front 2 legs and the back 2 legs, just offset them by a few degrees. So like the top.
Well, for the initial position, the way it's mechanically constructed,
Yes.
it would look like this, and then maybe at runtime we tell them to rotate a few more degrees, one way or the other. Yeah, sure.
And that could improve the feet not
It could.
each other.
This is testable. We don't have to debate it. We can just build an example and test it.
Yes. Okay.
But I like where you're going with that. Like, we can definitely revisit that idea. Yeah. Okay. It's a space background because my nephew's 11 and he's really into Kerbal Space Program. He's been trying to mess with shaders now. He's learning to program.
Good.
I cannot think of a greater compliment than that he's the only member of the family that's sort of following my example. What am I trying to say here? So I tried to make the shading system work even in like a KSP system, but modeling the entire Kerbal Space Program.
Oh.
But modeling the entire solar system, you start to run into problems with the numerical limits of what floating point and double longs can do in computer simulations, at least on home hardware. The math starts to break down because it can't hold enough places of precision. Yeah, anyways, I'm getting off topic. So we've got these bones here, and now if I rotate one of these, it won't be that way. It'll be maybe this way. Nope. It'll be... No, I think I had it before. Yeah, it's this way. So that one already works in the correct direction. And the femur one is going to be in a different direction. It's going to be what? Yeah, that's a Y. And the tibia is going to be a Y as well. Yes, it is, but it's reversed. That's okay. Oh, no, there we go. So just like that, I've almost got it standing. Right, it's not ideal pose, but... And then what we do is we've got an algorithm that messes with those three values to make the legs move the way we want. Now, I said at the start, it's like, what's the most straightforward way? I have this thing in here. This tab should really be something like that. This is ODE for Java. It's a physics engine for Java. And in theory, these physical elements can be applied to these bones, and then it would respond to gravity. and you could do things like have it fall over and land on the floor and try to pick itself up or whatever. You could see more of how it responds realistically to walking before we take it outside in the real world.
Oh, I see. That's
But that's a big it's there's a chart that shows how much work something is and how badly you need it.
uh-huh.
And this is a thankless tax. It's a lot of work for very little return at this time. So I would put that in a don't ever look at it again until you take like at the bottom of the list of things to do.
I see.
So yeah. It's better
What
to
would
get the algorithm working and then copy it onto the robot and make something happen.
what would be the first goal? Would be like to make it walk, have a tripod gait, right? That's the most basic gait.
The first goal would be stand up and sit down without hurting yourself.
I see. Okay.
And then do something like I had a way to stand up, but stand up such that your toes are this distance from the center, right? Because where's the ideal circle? I don't know. So I made it adjustable. And then
Oh,
you'd say this, and then if it's already standing up, and you say change the distance, the radius, it would pick up each foot one at a time and move it in to the right position.
right. And
Uh,
and what you pointed out, you asked me why is it bouncing up and down or something?
yeah,
That's a good question. It shouldn't do
we're gonna
that.
find out.
And
If it's working blindly and it doesn't know, I wonder if it's losing power. It would. One possibility is maybe somehow the other motors get weaker when one leg is off the ground,
I
but
think
they're
it's the
supposed to be
code.
super strong.
I think it's
One way is, I agree with you, that's definitely a possibility. One is the code.
uh,
One is, uh, um, so it could be electrical, it could be mechanical, it could be software. Those are your three options. That's
electrical.
it. It's the bones, it's the muscles, it's the power in the body, or the brain has gone loopy. Those are it, right?
Yeah.
It's if we use the biological systems as a metaphor. Um, yeah. So now that I've got all this working in the fixed meshes, I can take this out of here and put this into here. This is the same thing again. These are the STL files. So these STL files now work correctly. Let's go back to here. Let's remove this crab and test it again. There's my crab and it's in the ground. So that's fixed meshes. And then after that, it's this. Is that enough? Not yet.
Okay, I'm about to upload and send the new body and coxa to you.
Oh, awesome. And then all the numbers will change. Okay, so I've got the crab sitting on the floor, ostensibly sitting on the floor. That's the body file?
That's the coxa, I think, what I sent you.
Okay,
Wait, download to make sure, because
yeah. It's a big 14 meg file. Let's see here.
the other one is 45 megabytes.
Import, OBJ, Coxa.
Wait,
That does not
that's
look
not
like it.
that's not right. Wait, is that the one I just sent you? Huh.
I believe so.
Wait a second.
Let's try that again.
Wait, it probably. Wait. Maybe I did something.
Body new OBJ. I think I might have gotten the old one. Body new. Download.
I'll do a Cox on you too.
The new isn't a very good name. Numbering them will work better.
Yeah, that's true. That is.
We don't know how many times we're going to have to go through this. I feel like that's 10 times too big again for the body, but
Wait, is it because I'm doing something wrong? Am I? This is in millimeters. I export it. OBJ file. There's not even anything I can change.
when you export, what is the scale for the export?
There's
Is there a scale?
change. No.
Oh, okay.
So this, I don't even know. What am I doing? Oh yeah. Okay, I named it Coxa 2 this time. Is it bad to have like the files be such a high megabyte? You know what I mean?
Because we're only running one robot, I'm going to say no. If we were trying to run lots of them, yeah, we could shave that down. But really, what's the most important one to be focused on right now? Right? What do they call it? Minimum viable product? Do the least amount of work to get the thing running? What am I missing
You know
here?
what would be so cool if I somehow added like, you see the simulation? If I somehow run the simulation on like a OLED display or something, some type of display on the controller, so I can see what the robot is doing in the simulation.
I hear what you're saying. That does sound pretty cool. How does that positioning look?
That looks good. It just needs to be down a little bit, but that should be fine. Wait, where's
The
the
body
feedback
needs to
back?
come down. Okay. 1 second.
Wait, that's called a translation, right?
Yeah.
Okay.
Instead of this, I'm gonna do this. More. That looks good. That looks really good.
Yeah, it does.
What about from the side?
Oh, also the bottom of the body is under the map now.
Yeah, I'm not there yet.
Oh.
What about this from here to here?
Why am I seeing two things?
This guy's not in the right place.
Yeah.
Yeah, so that's gonna. I moved the body up,
I think the
but
body needs to
maybe
be down a little bit more still.
I think instead of the body being up, you haven't sent me the Cox, I haven't loaded the new Cox in yet.
Oh,
That's missing.
I
So
sent it to
instead
you.
of trying to mess with this now, I should open the new Cox that you sent me. Getting there. Coxa 2. Love it. Download. Hello, download. Okay. Then back to Blender. Take this out. Import the OBJ from Coxa 2. Right. That's still too big. Let's bring that down just a hair. And then align it. And this away. It's about 4 each, yeah? A little more than 4 each. That looks good. And then export as an STL as Coxa STL. Back into app. Select that one, select the mesh, reload the mesh. Okay, that's not a problem. I'm gonna hope for a, oh, yeah. I want to rotate this way. I want to go 90 degrees.
It's
Back to 0 now.
yes.
And then, yes, I should go back here and say, you set origin cursor. Oop, there we go. File, export, STL, reload.
Nice.
It's a bit low. That's the body, and then was there another one for the... It just loads the file, it doesn't mess with it. So... Legs, get, eye, Cox, set trans... Yeah, I can't do set translation. I have to do this whole... I don't need to rotate, I just need the translation. And I hope it's just this. Variable M2 is already defined. Yeah. Oh, because it's defined up here as well.
Oh.
Yeah, I don't think that did the job. That shouldn't have been Coxa. That should have been... No, that was right. Oh, that's wrong. This... Well, that's one leg, but... Oh, because it smashes the others back to... It doesn't do the position again. Position legs. So the translation on each leg is wrong. Oh, okay. Oh, okay. No, I've done this wrong. Get the leg. Yes. Get the local matrix. What's wrong with O plus equals? Add one. No. I get the local, I move it and I set it back again. Why doesn't it go? If I subtract it, does it go the other way? It doesn't move, but it should move. Crab. Cox, am I looking at the wrong one? Am I setting them all? Center left. Translation. Not moving. Because I set a position of the legs afterwards. No. Right. So this was a +1. Okay. If I make this +2. Closer, +3.
That looks right. Pretty close. 2 point, yeah.
I'm going to go down another hair. With nitty and picky. Okay.
I think it's supposed to be up a little bit more, but it doesn't really matter. It's a little bit higher because of the coxswain, because of the horn.
You want it up higher. You want it back to like 2.6?
Maybe. So right now you're moving the femur down a little bit, so it's in line with the coxswain servo, right?
Trying to. It seems to have vanished on me.
That's pretty weird.
There it is again. Ooh. Oh, I saw that. You saw that?
Yeah, it flew away. It sunk under
I
the
think
ground.
every frame it was adding more to it, I think. But
Oh,
why didn't this one also do it? It seems sane. In position legs, am I resetting every part of every position? But I'm also... Oh, I'm in the wrong thing. I'm adding to this value instead of setting it an absolute. Didn't move, but it should have. Nothing happened.
so we were able to make where you were able to make the coxa go to the right place, and you're doing the same thing to the femur, and it's not working.
That's right. I'm just trying to figure out why now. So this bone should have shifted when I changed like this value.
Right.
And all it should have done is to chunk a small amount. I get the translation
Wait.
of the.
Look under that. Does that matter? Do you have a different block with the same femur, and you made a 0 again under that block? Does
Oh
that
yeah,
work?
that would be resetting it. Absolutely. Yeah, and I was getting ahead of myself because we might not even need this.
Wait, so I think. Wait, so you were
That
changing
was
it.
well spotted.
Oh. Oh, so you changed it and then you changed it back, essentially. Oh, now it's flying away.
Now it's locked in place.
Okay, there.
Ooh, now we're getting somewhere. Oh, and I bet it's 0.6 because the other one's 0.6.
Looks like 2, maybe. It's a little bit more than this, I think. Still looks like 2.
Okay.
That might be too much. Maybe like 1.9. Oh wait, that's perfect.
Oh, that looks really good.
Yeah.
That looks really good. And our origin is right there in the center of the axle where we want it. And that origin,
Wait, this actually
if I,
lines. Does that line up?
it does if I look at it right on.
Nice.
And then, oh, and then that's the toe tip,
Wait, is
right?
the
Which is
body? Is the body on the floor?
it's a little bit off the. Like these legs are just about touching. Let me try this another way. It's a little bit in the floor. But what I can do for that is just raise this like 2.5, 5. That's looking really good. So back here in the crab at the very opening, raise this 4.5. Oh, we're getting there. We're getting there. So I don't need this. And this body mesh thing happened back up here. Fix meshes. Right? And then these position legs. Basically, this comes at the end of position legs. Position legs. Yeah, because we never really took into account the z-axis, right? This z-axis here is probably where it was supposed to be fixed. All good. It's all good now. So if I run that and then goodbye crab, add another crab. He's sitting on the floor. His shoulder joints look right. His knee joints look right. Or his hip and thigh joints look right. Fantastic. Fantastic. And which side has the screen? I can't tell at the moment. Can you tell which side has the screen?
Can you zoom in a little bit? Oh no. Oh yeah. Okay, this is the fan. That's the fan. So this, yeah, this would be the screen.
Okay. So, and that would be the front. If I pick the crab, so you see the green arrow? That's yellow. That's sorry, that's the y-axis. Y-axis currently faces forward on this robot, and the x-axis points out that leg,
Okay.
and that's fine. Okay, so I'm going to turn that light back down again. That's getting a little. Okay, it is now 20 to midnight here, and it's like 3 a.m. where you are. So I'm saving this.
Wait. It's 1:40 for me.
Okay, you're 2 hours ahead of me.
Okay.
You're Eastern Seaboard, like I don't know, New York or Florida or something.
Chicago time, yeah. Close.
Oh, okay, cool. I've never had the joy of visiting your lovely city.
Oh, I don't live in Chicago, but like the time zone, I think is called Chicago time.
Ah, gotcha. Okay.
Wait, actually,
Um,
I do live really close to Chicago when I go to college.
all right. So now that I've got all that, there's something about here's uh, there's stuff that's going to go in here later. Case. Um,
So all of these things that you just put down, these are all like I could potentially once we get all those working, I could potentially say like have a button for each, right? Or like a control for each,
or some kind of toggle where you swap through them. Yeah.
and then the and then after wait, okay, so stand up, walk, three at once, ripple one, ripple two, and then we can and we also need a different after all after we get it working, the basic ones working, we can add different modes for the walking, like different like how high up to lift the legs.
Options for each one, absolutely. So I've really quickly knocked this garbage together here. A right. So at least that not state. What are you about? You're not final. Final means it can't be changed anymore, and that's not what we're doing here. So somewhere else in the code would be something that changes the strategy, but then in here we could hard code it to something and then have it do each of the strategies one at a time. So we don't mention the do nothing strategy because we don't need to, but that's the default. And then here would be something like, because you don't want to write it all into one file or into one method. That would look crazy. Or even better would be how these are nodes. Like all these, each of these pieces. This is a pose. This is the crab. There's meshes, right? The material is a node. All that kind of stuff. Here they are. Here's a lot of them. Camera, limb, look at, mesh instance, that kind of stuff. So we could make a node for each of these strategies, and they exist under crab, and they know that if I look at my parent and my parent is a crab, and then I would say to the crab, here's what I think you should make your joints do right now. And then crab can be subscribed to that somehow and listen to those instructions. Or it could say, hey, I've got 5 strategies that I could use, and then maybe we add a node between them that's like the blender, where you say I want 10% of this and 30% of that. So it can walk, but it can also do that while standing up.
Oh wait, this is actually good because for the robot to turn, we need to combine part of the turning
Yeah.
and part of walking forward.
Right. If you want to walk and turn at the same time, how do you do that without tripping on your own legs?
Right.
You've got to be able to blend them together.
Also, one thing we could also add is a homing sequence. So right once I power up the robot will do the homing sequence because the robot can't just put all of its leg on the ground because it could just. Do you know what I mean? Like a.
The Dynamixels have to make a move first to know where they are or something?
I'm not using the Dynamixels, but how do I explain it? So okay, so for example, all the robot legs could be in different positions, right? When I start it up, before I start it up. And maybe we can have a homing position where it's sitting down basically on the skid plate on the bottom of the robot with its legs folded in a certain position, like a homing position, kind of like a do nothing. See what I mean?
Right.
So when I start up the
Well, do
robot,
nothing means freeze, but sit down would be move all your legs into the default starting position.
yeah, okay, yeah, basically that's what I was talking about. So just like a sit
Okay.
down position would be like the homing,
When your
position.
robot first turns on, the legs could be anywhere, and
And
the initial behavior is do nothing, so it freezes. So maybe actually sit down is more important than stand up. But swapping these doesn't really mean much at this stage. Right. So then if I knew the angles for somewhere in here, when we had this open, back in here in Crab, let's take a look at this. If I have the center left and I move this 10 degrees, that looks right. Okay, so that's 10 on Z, right? So there's a method in here. It's like private set leg angles, and then I give it a leg, and it's double coxa, double femur, double tibia. Sure. And then leg, coxa, and I have to get the rotation in that joint. Where that's not get, that's a get. Leg, coxa, get local. And instead of messing with position, we get the position, we don't change it. We have the translation and we don't want to screw it up. So basically I need to record whatever this matrix is. No, I don't. I am... We said it's a rotation in Z of some amount, right? And then we add that translation back in and we set it in here. And then, so what I can do is then now say set leg angles, and I give it 3 values, and the leg goes where I want. So then my whole walking strategy is changing these 3 values. Does that make sense?
wait, I think so. Wait, describe it one more time.
I'm writing a single method in the code where I give it the leg I want and the 3 joint angles, and it instructs the 3 joints to go there in one line, nice and tidy.
That's like forward kinematics. You give it the known joint
Yeah,
angles.
exactly.
And
Yeah.
so you're giving it known angles and the feet to move to the unknown position based on those angles, basically.
That sounds right. So I don't need this one, or this one, or this one. But then back here in the femur was a Y rotation. It was like, yeah. This is a rot Y, and this is a rot Y.
Also, I'm not sure if
And
this is
if I...
helpful, but a lot of people, I think this is how they do it. They use the inverse kinematics. So they give it a known XYZ coordinate, right?
Sure,
And then
you're absolutely right, but we're not there yet.
Oh, okay.
Yeah.
And then they're
If
able
you
to
know where
open.
the toe tip is and you can do the intersection of circles, then you can find the location of the knee, and then you can reverse engineer the angles, and then you know exactly what to send to the forward kinematic system to get the motion that you want.
Right. And then,
So
okay.
this is legs get I, and then we give it 3 values. So that would be initially 0, and then initially this value should be minus 40. What do you want this to be? Minus 90?
So like this would be the homing position, right?
Yeah.
Okay, 90. Wait, actually, wait, let me think. Can you look at the little oval brace you were talking about? Because that can't overlap with the plastic, obviously. Like if you look, yeah. Right there, you
Right, so
see?
that's too far.
I wanted it like as close as possible to that touching the thing.
Let's say 60.
Wait, on my model, it goes up past 90. I can send you a picture.
Uh,
Or you can just do 90, because I'm pretty sure 90 will work.
yeah.
I sent you a picture on Discord. Oh my gosh, my phone's on 1%. It's okay. But you see how
Well, I
it
mean, I
goes.
can do it in the computer, but it's a very close margin when it goes past there, right? No. That bone is actually going in. Is this
Yeah.
shoulder installed upside down?
1 second. I'm plugging my
Is
phone
this
in.
part upside down?
Give me 1 second.
Yeah.
All right, let me see here. Oh, it
Is this
is.
upside
Yeah,
down?
it is upside down. That's why.
That's crappy. Um, which means this might be like that, and this might be... What did I have before? I had this. And then I'm going... this model is upside down.
Wait, this one? Wait, that's not the femur. Wait, everything is right except for the femur, by the way. I think you just changed the coxa.
Yeah.
You made the
You said it
coxa
was
upside.
upside down.
No. The femur is upside down. Sorry. The coxa is right. Cause like if we look,
This
you
is
see the
upside down.
yeah, that's
This is
upside down.
upside down.
Yes. Cause you would need the
Well, that's an even bigger problem. That's going to hit earlier. No, it's not. No, it's not. I see.
yeah. Cause
So
you
take
would
that
want the
out.
you would want
Import
the
the
you would want the femur
femur.
with the servo pointing down to have the most
Do, do,
ground
do,
clearance.
do, do. This is the femur. This is rotated.
And it's actually symmetrical, so
No. Did you see what I just did there?
no.
I saved over the coxa.
Wait, I think you flipped it the wrong way. I think you just made it upside down.
I'm looking at the wrong part here.
Yeah, you made it upside
Yeah.
down.
What do you mean? You told me to flip it.
Well, okay, wait. Okay,
You told me to flip it, so I flipped it.
wait. It's flipped like. Okay, can you go back to Blender? I'll explain. Go to the femur. Okay, so flip that back how it was. Okay, now flip. You have to rotate.
Oh, this way.
Yes. Because the brace.
Oh.
Yes, like that. That's what I meant. and then you can just drag the other origin. Drag this origin of the left side to the origin, and then it should be, yeah, and everything should still work because it's symmetrical. Yep, there we go. I think that would be good. Now we should be able to go past 90.
Lots of room.
Yeah,
Lots
yeah,
of
yeah,
room
there we
back
go.
there. So we can go more than
90.
I'm going to stop at 120 because that looks like it might be touching. Maybe 115. Yeah, let's go there. And then this one.
We'll preferably want the tip of the foot to be pretty close to the ground, right?
Yeah.
Or even touching the ground, or slightly above or something.
But not through the ground because it's supposed
Yeah.
to be resting. 50. That's pretty good.
Yeah, that looks pretty good.
Okay, so that's 150 and that's 65. So back here, excuse me, I'm gonna boop there. That's gonna be and no, this is way more than 30. What happened there? That's how it was. And then it dropped to 30. So that's 150. And then this would have to be set to not going to do that just yet. I gotta recheck that we haven't blown anything up here.
Oh,
Add a
also,
crab.
I have a question. So, how do you think we should control this? Do you think a RC, like a RC remote, is a good idea? Like some type of
Well,
remote?
first I want to be able to simulate it and know that I can make it walk, and then I will worry about how to talk between the various items.
Okay, I see.
It's just you're absolutely right to ask the question.
Mhm.
I can't focus on all the parts at once because I have a small brain.
Bro, you have a small
Um,
brain. Okay. Bro,
it's
the way
only
you're
so
working
big.
is crazy.
There's only so much CPU and RAM in my head, right? Okay, so which leg are we looking at? I'm looking at this leg.
But it's definitely good that
So,
you're correcting me because I have no idea how the workflow actually goes.
I mean, I had to make it up. There was no one to tell me. So my guess is as good as yours. I can only tell you if I've tried something and it had gone horribly, horribly wrong. I want that to be positive 150. So that's, yeah, when I put those two angles in, that's what it says it's going to do. So if I go back to here and I say, and I undo this, it should move. Can I close this now? I really want to. Supposed to move all the legs to do that. Right? All the legs to this position. Is that being called? It's only reachable in the whole switch. What is only reachable in the whole? Is the only? There's a word missing. The switch label is the only reachable in the whole. Okay, this switch case. This switch label is the only reachable case in the whole switch. That needs work.
Wait.
If I
A
put a
second.
breakpoint here, never gets hit.
I
Never
think
gets hit.
I don't know if this is necessary, but I think I should tell you. So can you go to the simulation thing? Okay, so right now, all the legs are mounted, like the legs aren't mirrored, right? Is that important?
Right.
You see what I mean? Because the
For the
left side,
purposes of simulation this is grossly correct enough.
okay,
Absolutely, you can flip them and mirror them and
okay,
load another set of legs for the other side later.
uh-huh,
I think in a
okay,
perfect world, you don't flip them because it makes it easier to do the math. You don't have to flip half the numbers on one side and you build 6 identical legs. That's easier.
okay, I
What do
see.
you say?
Uh,
If you
Probably
have a
true.
strong argument the other way, I'm listening.
Let me think.
So I'm going to try this. I think it stopped applying my updates, so I have to restart it. ODE, add a floor, in the scene, add a crab. That's unfortunate. There was an angle in there, and it has lost that angle. So, where's my leg class at? There's my crab leg class, and in here I need to put
I'm not too completely sure about the code, but if you mirror one side, right? If you want both of the legs to do the same thing, it would do the same thing. If you don't mirror, it wouldn't do the same thing. It's like if you want the leg to rotate to the left, if you don't mirror it, it'll rotate to the right on the other side. But if you mirrored it, it would rotate to the left. But I'm pretty sure that's
yes. Only
fixable in
the
code.
shoulders would need to be adjusted. Hopefully, but that's only 3 motors instead of all 6.
Yeah,
Is my hope. You're absolutely right there.
but that's fixable in code, so I think it should be fine.
Set. And when I set the angles for here, this 45 and this, I only care about the root joint, right? So this is front right angle coxa equals 45, and then this one is plus 90, and this one is 180, and this one is da da da. Whoa, is da 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 da, and this one is plus another 90 again. I believe it's as you no. Look, they're like stacking on each other. That's interesting. Why are they stacked on each other like that?
Is that because it's not mirrored?
Uh, each one is a
Wait,
small amount more than the one before
oh yeah,
until
that's
it loops
true.
all the way around, and
Huh.
it's something to do with the way the loop is running. With something to do with this is not working the way it's expected. Set angle. Uh, Well, it's 12:05. I guess I'm gonna have to take a crack at that tomorrow, sometime after I've done everything else I got to do tomorrow.
Okay.
Same bat channel, same bat time tomorrow. I'm gonna share my codes, what I've got so far, on GitHub. Are you familiar? Are you familiar with
Yes,
GitHub?
I am.
Fantastic.
Kind of. I'm not. Like I downloaded some things from there, like some code I've seen
Okay.
some stuff.
In the general channel. Is it in the general channel? Earlier. Yeah, up in here. How do I copy the message link? Yeah, I'm gonna paste it at the end so you can see what I'm talking about.
Also, when you work on this tomorrow,
Yeah.
would you mind like texting me? I want to watch. Like this is interesting. If you're free.
Yeah. Did you record this at all?
Yeah, I did.
Sweet. Where we're gonna put it? Can I put it on my YouTube?
You want to put it on your YouTube?
Do you want to put it on your YouTube?
Can I put it? I want to put it on my YouTube.
Well, it's a collab. You link me in the description, and let's make it happen.
Or you can record your POV too if you want.
I should have. Yeah.
It's
then.
okay, but I feel like this is actually really good because not a lot of people post the process of making this stuff.
Yeah. And we definitely have 10 minutes, which is like the minimum you need.
Yeah. They just skip over everything and just somehow the robot starts working. But
Yeah. They don't show all the behind the scenes like you said.
Yeah.
So this is not a big deal. This is I can't add that just yet, because before I do, I need this, and this, and I need those to be in a zip file. I really don't want to put them there because the class is hard coded to those values, and that's a problem.
But what do you mean? Like the dimensions of my robot?
I mean, getting these files in order to run the class has a hard coded path to a place on my computer, and that's a problem. So just before I check this in,
if you move it to a different folder, then you would have to change the file, like the
when you try to run it, it's going to die because it says I can't find that folder. This is from content root. We're going to try that. I don't know if that's going to work. Let's see.
Oh, also you would probably suggest foot sensors too, right? That'd be good, right? Foot sensors.
Yeah. Okay. So
it knows when each feet is actually on the ground.
Agreed. And I wanted to mention earlier, I think it would be worth it to. I've seen some guys who they get a 2-part epoxy material. Not epoxy, sorry. Here there's a local store called Associated Plastics, and you can buy rubber for mold making.
Oh, silicone. Yes, I've seen that.
Right.
For the tip of the foot to make it durable and non-slip resistant.
Well, they get the soft material and they 3D print a hard exterior
Yeah,
shell in
and they
two
mold
parts, like an
around it.
injection mold. Almost. You can make it a removable foot. The
Yeah.
point is that the pressure on the foot pushes the button without allowing dirt to get into the sensor, the contact area.
hmm That's really what I
So
need.
yeah, and if it's removable, it's like that thing. If you mold it around the foot in a way that's unremovable, well, you're kind of screwed, and it's gonna be hard work to make more feet.
Yeah.
Uh, if they're like a sock that you can take off and put on,
Yeah, that's what I was
that's
trying to trying to brainstorm to prototype. I still can't figure it out. The foot is like, I don't know.
you
I've
will.
Yeah, I will. I've been through
Yeah.
3 different designs for the foot, and this
Only
one's,
three.
yeah, only three. It's the
That's a
last three.
great start. Right. So I changed those. Did I change those paths? I just gotta recheck that one more time. These ones have changed. That one's not. So and I think we're good there. And I didn't write a single unit test, so this is kind of bullshit. There we go. Add crab class and STL files. Oh wait, let me in. Fantastic. Register new crab class. Okay. And I shared with you already the link.
And this is going to, okay, so basically the code, everything we did today, you put it on GitHub, right?
Yep.
Okay, that's awesome.
So you can grab that, and if you can compile it with Eclipse or something, then you can run all this program yourself with all the latest changes.
Okay, I see. Awesome. That's
So if you don't want to wait around for me tomorrow, because I got to do chores and stuff, touch grass and that kind of thing. If you don't want to wait around for me, you can try and figure out why these legs are funky, and you've got what I did over here, so maybe you can step through it and figure it out,
yeah, I can.
right?
I'll try. But I don't even know how to set anything up, so like I don't even know what JavaScript is. Like I don't even know
It's
the
it's
editor you're
it's
using.
yeah. This
I
is
mean,
Eclipse.
I can figure. Oh, Eclipse. Okay. So that's like
Sorry, no,
a
sorry. This is IDEA. It's all written in uppercase, and it's by a company called IntelliJ, and it's very nice.
Okay, I
But
see.
it's not free. You might
Oh,
be able to apply for a student license if you can show them your college admission,
okay.
and then it's free. Only until you
Yeah,
finish school, right?
that's how I got Fusion.
Nice. On the last day of school, get
Uh,
your student ID renewed, and that way it's valid for a year, and you can,
that's smart.
yeah,
I
buy
see. I
you some
see.
time. It buys you another 364 days.
So right now you're
Uh,
paying for it though?
yeah,
Oh,
yeah.
I see.
I'm a
Okay.
47-year-old. I'm not in school anymore.
Yeah. Okay.
Yeah.
Um, yeah, just tomorrow whenever you're free, I'll probably be
I will
available.
ping you on Discord, and you can send me messages, and when I'm available, I will respond. But
All right, thank you
I
so
can't
much.
say exactly when I'm going to be able to sit at the computer and do the thing, right?
Yes, it's okay. It's just whenever
All
you're
right.
available, just text me and I'll try to be available, which will probably.
Fantastic. If I just have a little fun with this. If I do like this, and then I go down into here like this, we're gonna pick some hideous colors. I know. Yeah.
They're easy to tell apart.
Oh yeah. That's inside the femur. This one, and here we
I also thought
go.
about using composites to
Dun.
make the parts instead of 3D printing, like carbon fiber. Be pretty cool.
There is no mesh in the toe. That's silly. This is a block. Uh, green. Right. Or we could do a strategy where whichever leg is selected becomes a different color. And
Wait, why are you changing in different colors? Just so you can see each part.
see, see the bones better, that's all.
Okay, that makes sense. Awesome.
But I'm not going to save it like that. That's just for, I'm just goofing around
Visuals.
now.
I see.
Yeah. Okay, so I think it's something about setting these angles that when it goes wildly wrong. I don't know yet why it would be.
And I also have
There's one idea.
I also have all of the inverse kinematics equations to be able to give the foot
Fantastic.
any XYZ coordinate and for the foot to move to that point.
Well, now you just have to write the code that does it. Ha ha. No problem.
I have the code in Arduino IDE though.
Hey,
Oh,
hey,
so
who's good?
that's
Who's
the
got
home
two
version.
thumbs and rocks? This guy. There's your sit position right now. It just instantly snaps the legs to that spot.
That's
But
awesome.
we can add a way to blend it to there.
To interpolate like the motion, right?
Yeah, exactly.
See.
Yeah. So now the stand up would have that. We'd write that in a way so you can say how high do you want to stand, how far
Mhm.
apart do you want the feet when it's standing.
And we can give it different modes, like a normal mode, off-road mode, and we can base on how high it
Where,
stands based on that.
yeah, the sky's the limit. So let me just check that in. The beauty of the small commits. That's what we like. Small commits. Um, uh,
Wait, how are you doing what you're doing right now? The GitHub. Like, okay, so the only thing I'm familiar with GitHub
this is
is that.
GitHub Desktop. It's an app
Okay, and
from GitHub
you're somehow able to just all the code you've written in the IDE or the JavaScripting, you're able to just
in Java, not JavaScript.
okay,
But
in
yes,
Java,
go
you're
on.
able to just put that on your GitHub.
Yeah,
Okay, okay, see.
it's already part. I see. I already had this project on GitHub, so all I had to do was add a
Oh,
few files in a new branch. This branch, this branch is branched off of dev. I don't know way to illustrate that, but it's like I made a copy of all the code at that moment, and then I
uh-huh.
started putting all my crab stuff only on the crab robot branch. And when it's ready, I can fold that back into the dev branch, and then anyone who has dev will get the crab robot. But for the while it's being built and tested before it's
Uh-huh.
ready for other developers, it lives
Uh-huh.
in this branch.
I see. Okay, makes sense. Well,
All
thank
right.
you for everything. Like, actually.
It's such a pleasure to talk to someone who is going where I have been, or who understands even a little bit of some of the things that I've done, and who's
Uh-huh.
interested in it. So it's so nice to meet a kindred spirit.
And I
Thank
don't
you for
know,
this
like
experience.
the way you're actually like locked in,
Yeah.
like your attention span, it's good. A lot of people now like they do something for like a minute and then they can't do it and they just give up basically. You know what I mean?
The phones destroy their attention
Or like
spans.
TikTok.
Oh, I've never touched TikTok, and Instagram is already a problem. I look at it before bed, and I
Uh-huh.
send memes to my wife. And I read somewhere recently a really great quote. It said, um, boredom is essential for, not essential, but boredom is a huge factor in inspiration.
Yeah,
But if
I've
you're
heard
on
something
Instagram
very
all the
similar.
time, you're never really bored. You're just
Uh-huh.
sort of gambling for little bits of dopamine.
Yeah.
Yeah. There was a moment today when I was like, yeah, I could pull up my phone for 2 minutes while I'm waiting for somebody to do a thing, or I could just leave it in my pocket and try to be bored for a second.
Yeah, I just brainstorm
That's
new
super,
ideas.
super hard. That's the way to be, man. I think you're
All right.
doing the right thing.
Thank you.
Tomorrow,
Tomorrow.
get some good rest. Be kind to yourself. We'll talk soon.
All right.
Good
Just
night.
text me. Thank you. See
Will
ya.
do.